My name is Marshall Hebert. I am the Dean of the School of Computer Science at Carnegie Mellon. What makes this place so special is an exceptional level of collaboration, experimentation for creating new things, and of course, an amazing enthusiasm for the technology.
My name is Virginia Smith, and I'm an assistant professor in the machine learning department at Carnegie Mellon University. The goal of my research is to enable machine learning under real-world constraints. One example of this broad area is the application of federated learning. Some examples of federated learning include learning the activities of mobile phone users, predicting health events like heart attack risk from wearable devices, or predicting pedestrian behavior in a fleet of autonomous vehicles.
Federated learning allows you to train statistical models in a massive network of remote devices. And all the user data are kept local, so the user privacy is protected and the network bandwidth is saved.
My name is Hossein Mohimani. I'm an assistant professor of computational biology. 23,000 people die from antibiotic resistance every year. My goal is to find a cure for these type of infections. We want to discover novel antibiotics by analyzing large amount of data so that we can isolate them and use them for our benefit. People all over the United States send samples from their garden soil, and our goal is to figure out if any of these samples have some novel antimicrobial small molecule.
My name is Mahadev Satyanarayanan. I go by Satya. I am the Carnegie Group Professor of Computer Science at Carnegie Mellon University. I am working on edge computing. The easiest way to understand edge computing is to contrast it to cloud computing. While cloud computing has many benefits, it would always be at a disadvantage for important applications where latency is crucial. Edge computing places the compute resources needed much, much closer. My team and I are the pioneers in this space, and we have over the past decade created the underlying science and proof of concept implementations that leverage edge computing.
This is an example how edge computing helps us build scalable systems for video analytics.
This kind of research would not be possible just with a person like me or even with any one of my collaborators. It took all of us, and so the whole is much more than the sum of the parts.
The School of Computer Science has reached a level of maturity that now it can be combined with other domains to create completely new disciplines. Within the next few years, we will see those new disciplines emerging. This is a very important aspect of what we do.
Carnegie Mellon is a really fantastic place to be because there are so many students and faculty who have diverse expertise. It's a great place to work on really cutting-edge problems.
We can actually train models using half the bandwidth while still retaining the same accuracy, which means that we can actually train models at really large scale.
What we are doing in this lab could impact the life of millions of people. That is what motivates us to continue doing what we are doing.
We apply our pipeline on several different datasets, including the samples from the International Space Station, and we discovered 7 new small molecules, which are potentially some new antibiotics.
We create things that actually work here. This is a place that solves real-world problems and comes up with real-world solutions. And if that motivates you, this is the best place in the world for that. Real-time, edge-based human cognition is happening here.
Automated antibiotic discovery is happening here.
Scalable and robust machine learning is happening here.
What's next in computer science is happening here.